Okay. Right. Um, Good morning. Okay. Oh, very fast one.
Thank you. Very drinking matcha, so I gotta match
Good morning.
You know, it's funny because the links that you sent from the creative coding class it's the class I'm enrolled in right now. And the links that you sent are from, I think, a previous version of the class, which is a lot more in depth than what we're doing right now.
Oh,
Do you know if they changed it?
for what?
Like, because you linked some like creative coding things to go over like GitHub and stuff, and that, I think that's a previous version of the class. But I was going through, it looks way more. It looks like it used to be a lot more in depth than it is now.
The creative coding class?
Yeah.
So I used to teach the creative coding class when I came here 5 years ago. Maya, did you take that with me? Yeah, I think you were the last one who made it through. And so I was doing creative coding initially, interactive art and web. And creative coding, interactive art, strong points of mine, web was not. So I handed that off as quick as I could. And then we hired Michael Kasins, who is a badass computer scientist. And really one of his research areas is the pedagogy of computer science.
Yeah.
And so he obviously took over the intro creative coding classes, and that allowed me to move into the Sonic art fully, which is where I want to be. And so he is doing his flavor that he has researched and seen as being the best for outcomes. So he doesn't go very deep into GitHub, if at all, anymore, I remember. And but yeah, it's just difference of instructors at that point. Yeah, trying to make sure, because it's required for everyone in the media arts degree. And so the poor filmmakers who don't want to do coding also have to do coding, and then they kind of hate us.
Sure.
And so we're trying to make sure that it feels like everyone can really come at it.
Totally. That's super cool.
Yeah, I think it's some great shit that we're doing.
I was just curious because I walked around and I'm like, oh, this is the same class I'm in. I'm like, whoa, this is
Totally different. It looks kind of like it. Yeah, and
exactly the same.
we've shared shells, so the fundamental structure is the same. But okay. Let's move this somewhere so I can see how it'll work. Cool. Oh, well, you'll receive your flogging later, I suppose. Thank you, though, Bearcat.
Did they read the kernel in this one?
So there was it should be on there. there was a security update for Macs that came out last week or whatever. So they have done some things.
Oh, good. Yeah. And then you know how you could decide it to adopt. Yeah. Permanently stay there. You have to drive. Yeah, and then it will stay there. It's all new.
Let's just- So we're missing Jared and Roy. Let's see, here's Roy. I think Roy actually is gone today, so I think we have everyone. What's going on here? What? Why would you keep that on that second line? Okay, whatever. No one cares. Okay, and just to make life nice on us, let's go editor, font and color. We'll do default. Okay, and then how are you doing this morning? Good. There we go. What's the plan? We're gonna learn some more about coding and make some sound and yeah, I think it'll be fun. I don't know. How is everyone this morning?
Great.
Great. Any questions that came up from last week because you've been chewing on shit this week? Yeah.
Yeah, I was messing around with the little mouse program, and I know that you can output, and I thought it'd be really nice to know where you are on the scale and the output and all that. So I was messing around with it. I was able to get it into the logs,
Yeah.
into the window.
Yeah.
I was trying to get it to give me the variable, the variables at the mouse cursor like the tooltip, and I couldn't find a way to activate that outside of supercolor.
Yeah, I don't know either. Yeah, but we can look at post window today. That's actually on our list of things to do. Oh, so I have moved my post window over to the right. So when you open it up, your super collider looks something like this, right? You've got help down below, post window up top, and your workspace on the left. And I've also gone ahead and changed my environment. You know, I just don't like the way that looks. So just as a reminder again, editor, fonts and colors. I will work on, if you want the coloring that I've got, I will work on adding that in. But just so you know, in terms of setting up the windows, you can actually undock help if you want, and then you can close it whenever we want it. It'll come back up. Wow. That crash card. Oh, here we go. Undock, detach. Command D opens it up. Likewise with the post window, you can drag. I like to have it on the left side for some reason. That has just always worked better in my brain to have it on the left side. If you drag it to the left side of your IDE, you'll eventually see a little space come for it. So if you want to follow along that way, you're welcome to. Otherwise, leave it on the left or leave the editor on the left and you can have the post window on the right. As a reminder, when we open up Super Collider, we get all kinds of nonsense, and you are not going to have nearly as many of these compiling directory lines. I have a whole bunch of extra things loaded in, some machine learning stuff, and some extra math things that I use for various projects. So yours should be fairly minimal, but ultimately what we want to see is that your library compiled and how many files it compiled. I've got a couple errors, but that's my own fault. And then class tree initiated, again, really good to see. It tells us, welcome to Super Collider, and it's been able to index the help files. It tells us all that. So just a reminder, you should see some information like that when you open up Super Collider and get the server or the language running. If for some reason your interpreter or language ever quit while you were working on stuff, you'll see down here, the interpreter now is white, inactive. We go language, boot interpreter, and we'll see all of that same information printed out again. and then we'll see interpreter is active. Likewise, just like the engine, you can actually click here and ask it to recompile class library, reboot interpreter, or quit interpreter. The only reason you would recompile the class library is if you're developing your own classes for SuperCollider, which we are not going to do this semester. So, but if you find yourself in the future wanting specific functionality that SuperCollider doesn't have, you can write that functionality in C. You'll have a great time. I've done it a couple times. I did not have a great time. Cool. Any basic questions on the environment?
I guess this is not the environment, but looking over my notes from last week, I wasn't entirely. I guess I know that .ar and .kr is just an audio rate and control rate, but I'm not quite clear on what that means.
Yeah.
When I should use either.
Did you have a question as well, Charlie? Does that relate or is it separate? Yeah, man. So, what am I looking for? Is that what it's called? Go. Okay. So, let's say we have 1 second of time. And there's actually 3 that we're going to talk about. There's AR, there's KR, and there's IR. So let's say we have, this is 1 second in time. Okay. And if we have a sine wave at 1 hertz, how many completions of that sine wave are we going to have in that 1 second? One. So it's going to look something like this. Except it'll be even, and you won't have this weird short loop, far loop, whatever, right? Okay. So in that 1 second of time, at audio rate or the sample rate, let's assume our sample rate, we'll do a new color here. Let's assume our sample rate, and we're just going to use SR for the time being, is equal to 44.1 kilohertz, which means what? Yeah, so 44,100 times per second, we are sampling our audio signal. So we would break this 1 second up into 44,000 little blocks. No, but that's the whole point, right? So let's assume this is 44,000. Essentially, we create this stepped waveform. It's not smooth. It's not an infinite amount. So we have to what is called quantize down. We'll use this terminology in Midi as well. So it gets used both in audio and Midi. But quantization essentially says we're working in a digital world. We have to have discrete values. So we've chosen, if we've got a sample rate of 44,000, to have a set of discrete values, 44,100 times per second representing audio. If we have a UGen or unit generator, which is what this sine oscillator thing is, running with the method .ar, it's essentially creating whatever our sample rate is, it's creating that many samples per second from that unit generator. Does that kind of make sense? That's the easy one, I feel like. This assumes some remembrance of basic audio concepts. If it doesn't make sense, it's okay. Just know that, like film or something, if we've got 24 frames per second, right, you're having 24 pictures per second shown on the video that's being played. Same thing in audio. KR is control rate. Oh, is that not showing up? Oh, yeah. I forget that these monitors really are piss poor with blue. I'm so sorry. Control rate. Is that any better? Yeah. Yeah, right. Control rate. And this essentially is a way of reducing overhead on our computers for processing. Control rate, I think, is based on the block size, which is 64, I believe. And so essentially, for every 64 audio rates, we'll create 1 value. No, so because it's its own signal. If we create mouse x.kr, .kr, this is essentially going to create what is 44? divided by, what is our block size? It doesn't matter. I think it's 64, whatever. So if we've got 44,000 divided by 64, we're creating roughly 689 samples per second. And so what that does is it 689 times per second, it queries the computer and says, where is the mouse at? Give me that value. It's not querying the computer 44,100 times per second, and that would increase our overhead on resources. Does that kind of make sense?
So you would use AR if you're exclusively doing audio.
If it's something that you're going to ultimately hear, you want to be in AR land. If it's something that's just driving data for an audio rate signal, it can be in KR land.
But you could use AR for
Yeah.
something that's driving audio, but it would just be really resource intensive.
Yeah, which, you know, when this program was built in 2001, that was something we really had to think about. Computers at that point were equivalent to worse than iPhones today, right? So we would quickly run into resource issues with trying to do real-time sound synthesis. It's the same issue as we look at other real-time render environments now, where they're going, okay, what kind of tricks and games can we play to get our real-time render up? And we got to be smart about it. It doesn't mean that we shouldn't still think about that for audio now, and in 20 years, we'll still think about that for video real-time render environments, because we want to still be optimized in case we want to do crazy shit. But it was really more of an issue 20 years ago.
So KR is just
Fewer samples per second.
and to be specific, what were so 64 blocks.
64 samples per block. So let's see here. I think actually, if we go, we'll pull up help. Oh, and then drag this down. Find in page. No, here we go. Search.
So when using KR, is it going to give you a lower?
If you did audio at KR, it's gonna be lower resolution, and you're gonna run into oversampling issues. Oh, my caps lock went on here. So I want to go overviews. Well, here, let's actually do this. Okay. We'll go methods. There should be a description somewhere in here. I will look this up. There's a great, somewhere in here, there's a great article that describes really specifically the difference between AR and KR. Let's do this. Collections. We'll actually go Eugen's, and I'm going to show you a little bit about this today too. So this is the parent class for the Eugen, for Eugens. And there should be. I thought there was a discussion in here somewhere. But maybe there's not. Well, at any rate, so yeah, I think it's a block size of 64, but let's make it so I can boot my environment. We're going to put output for the time. Oh, those of you in Zoom land, sorry, I'm not sharing screen yet, but that's okay. Now I am. So now we can go Zoom audio device. I think I can boot up here. And I hit Command B on my computer to boot. So block size here is 512. And so I believe every 512 samples, we're getting a KR sample. Every 512 audio samples, we're getting a KR sample.
But the block rate is, it is still relative to the same.
Yes.
Okay. Cool.
Yeah. And then the last one to be aware of is something called IR. And IR stands for initiation rate. And that's for Eugens in which we just see a single value. So it's not going to change. It's not going to be a signal that's moving. It's just going to send out the same value over and over again. And so we know we don't need to compute it every time. So everyone kind of understands the basic architecture of a computer and what with clock speed on the CPU. Essentially, clock speed says how many times per second can the CPU calculate a set of basic problems. And for each thing we need to solve, that goes against our clock speed and the number of problems that the CPU can solve in a second. So if we can reduce that down, we can increase our basic processing power. It's worth, we're going to talk about optimization later in the semester, and we'll re-dig into a lot of this stuff. But if we're kind of at enough of a black box level right now where you feel comfortable with it, I think we should move on. Is that okay for everyone?
Yeah.
Great. We will get back to some of this though. Absolutely. Okay, now, questions on, let me get my notes pulled up here. Any questions on installing SuperCollider that anyone had lingering from last week? Any questions on booting the server that anyone still has? Has anyone tried to boot the server and run into any issues?
No issues yet.
Yeah, I am curious about the Chromebook, and we will talk about that more. So remember, SuperCollider has two programs. There's the interpreter, and then there's the audio engine or server. In order to actually create sound or modify sound, we have to turn on the audio engine or server. So initially, if you look at the bottom right of your IDE, there's this like server and it's all white. So it means it's not booted. There's a couple of ways we can boot the server. One, we can actually click on this server thing and hit boot server. And then we'll notice over here, it tells me booting server, localhost on loopback address. It tells me the number of devices I have available that I could use for audio input or output. Ultimately, it tells me which device did I choose, did the computer select for input, which device did the computer select for output, what sample rate are we running at, in this case, 48 kilohertz. And then eventually it tells me SuperCollider 3 server ready. We also notice that down below, our server information turns green, and green means go. If you're on a Mac, the easiest way is to open a program called Audio Midi Setup. And then you can choose the sample rate for each of the things. Because I'm recording on Zoom, my audio output device for SuperCollider is Zoom, which has a fixed sample rate of 48 kilohertz. So I've had to change my microphone sample rate input to 48 kilohertz. That's why, so some of this stuff you'll just kind of ignore because otherwise it's going to cause you some unhappiness. Other questions on that? Lovely. Nice if I can make this smaller. It doesn't matter. 44.1 is great. 48 is great. Honestly. Out of the way. Right there. Okay. Next thing, to create a basic synth. So let's clear. Let's clear this new page. So whenever we're working in SuperCollider, essentially what we're doing is we're creating synths. And a synth is a collection of instructions for how to process and ultimately output audio or some sort of controlled data. So we can have a whole lot of synths running. To create a basic synth, we can go sineos.ar, play. I'm going to turn my volume down, and then I'm going to hit Shift Return. I'm going to go to Zoom. I'm going to go, hey, Zoom, audio device output needs to be Big Knob Studio. We're going to try this again. And notice down below, it says now I have one S, that means one synth playing. That's quite small, I realize. We can also verify this by opening up the show node tree, which shows that I have one temp synth essentially playing. To stop my synth, I hit Command period. And then we go back to our node tree. Notice there's nothing there. And down below now it tells me there are no synths playing on my server. Synth. Shift return executes a line. Command return will execute a larger block, but you can use them pretty much interchangeably. Command period will kill everything, just as a reminder. Anyone who has headphones, feel free to use your headphones. If you don't, think about bringing them for future weeks. What's the problem with command period that we run into pretty quick? Let's say I've got a synth here, and I'm going to add in an argument for frequency. We're going to do 200. And then we've got another one that we'll put at 232, 376, 976, just to be weird. Okay, so we've got these 5 synths, and I can play them all together. 1, 2. And we're going to also add in mole arguments of 0.3. And I'm distorting, and if I wanted to, I could verify that by saying show server meter. I'll come around and look in 1 second. So notice we have 5 synths going. That's great. But let's say I wanted to kill one of them because I realized I didn't like it. We can't do that in our current setup. It kills all of them. So what would be nice is to be able to individually address these synths as they're created. How might we want to do that? What's our method in computer science or computer programming to reference a piece of data later on? So doing creation. Use command control plus period to kill all playing. So what is a variable? Yeah, sure. I like that. What else? What else? Could be. No, not typically. Yeah, it's just a storage location. So we can say later, what did we store there? So a variable references some piece of data for later use or retrieval. Okay. In SuperCollider, there is something. So if we're creating a synth-def, we can actually use VAR is how we signify to the language that we're going to create a variable. And so, for example, I could create, here, we don't need this to be a synth-def. Value. I must say value is equal to 33. Value is equal to 7. Show value. At the end, we get a printout that says 7. So we created a variable called value. We initially assigned that value to equal 3. I then overwrote that and said, let's have it equal 7. And then I just had that post in the post line. And remember, SuperCollider will post whatever the last command is, but if we want to be explicit, we could add the method post line. It's still going to post 7 over here. If we wanted to be cute, we could do something like the value stored in value is seven.
So what are the, so to make variable of value, what are the other?
What do you mean?
So you wrote variable value. Does the word value actually become?
So I'm declaring this namespace value as our variable. We could have it be something else. It could just be val.
It could be any.
It could be anything. Needs to start with a lowercase character, typically A through Z. Numbers are bad, not uppercase. Then you can use A through Z, numbers, underscore, dash. And you want to avoid special characters. No spaces, obviously. If I try to execute this now, notice I get an error. Variable value is not defined. So it goes value equals 7. You never instantiated or declared that value name, that namespace of value. So I would just need to change it to val. And now our code, whoops, will execute no problem. Okay. Declare a namespace of val. Assign a value, a value to override our namespace. New value. We can also use, because we can reference this variable, we can do cool stuff. Like, so we can say var val. Val is initially equal to 1. Val doesn't have to be. Oh, it does have to be. When we're declaring var, it needs to be in some sort of what do we call it? Closed, yeah, closed system essentially. And so we cannot use, if I tried to reference val outside of this, if I go val, I'm going to get an error. Val is not defined. Val is only valid inside of this space here. If you wanted to see it at the end, again, SuperCollider will post whatever the final command is. So in this case, it's still going to post 7 for us. But I'm just being explicit with it. Yes. We're going to get to that. We're going to get to that. Yeah. 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 Every time you write
save that file, because it's maybe having that file is saved.
Okay, anyway, so we can reference a value and then overwrite it. So we can say, give us the value of that's stored in this variable val, multiply it by 2, and then restore it in val. And then we could grab this set here. Value stored in val is 2. So we had val is equal to 1, val times 2 is 2, and we pulled it back. We can then go further and say val is equal to val times to the power of 4. We get 16.0. That should have stayed as an int. Anyway, that. Anyway, does that make sense? So we can reference values over, and values do not have to be numbers. So val could be a string. And we can still reference that. So variables can hold all kinds of data. However, there's going to come, so if we're looking at our earlier example here, let's say we wanted to change, who was it? You asked if we could change frequency with a variable, right? Oh, yeah. Yeah. So we'll get to that. I mean, it's a full language. So we can do anything you'd normally do in a language, you can do in it. You just got to eventually figure out how to do that. So, but first, let's say variable, we're going to create a variable called signal. And we're going to initially assign signal to be equal to sine os. And then ultimately what we're going to do is we're going to play signal out. So that still works. And we'll create a second variable called freak. And we can say freak is equal to what we used last week, mouse.kr. In this case, we're going to use range as a follow-up method to kr, which essentially allows us to set the output range of a unit generator. And we're going to say 200 to 400. Oh, you'd be so good here, 200. Oh, in order to use your variable, you actually have to use your variable. So my problem was I had not placed it into the argument freak. If I had freak declared below when I first used it, what's going to happen? I'm going to get an error that says it doesn't exist. Big long error. Sine os argument freak has bad input nil. So obviously I haven't done what I need to do. We can, just as a reference, we can assign values in variables initially, but it's going to obviously use whatever's stored in that variable by the time it's called. So declare two variables, assign the mouse value. The signal references the variable frequency. Yes. And assign it variable sig output sig to. I am recording all this today, and I will make sure that we forward the recording to you all. Yeah, sorry I didn't record last week, but it's okay. So, okay, the other thing we want at some point in is we probably want to be able to actually reference the synths themselves in variables. But here's the problem. So we could say var synth, and then we'll go simple. So we'll say synth is equal to Sine Oscillator. We're not going to do anything fancy. Dot play. And this plays. Problem is, if I try to reference synth again, notice synth is not defined because it's bound to this smaller environment. So there's a thing that's actually known as an environment variable in SuperCollider, and we can think of these as global variable, meaning they're available everywhere. Global variables, by default, the letters A characters, A through Z, are assigned as environment. So if I replace this with A, I reference A again, notice it now, it tells me this is a synth. And so I can actually now go, what this allows me to do is I can now, free the synth more eloquently. So I can go A.free, and it frees the synth. Stopped it. I didn't have to do command period. This becomes particularly useful when we borrow our example from up above. So we get an A, B, C, E, E. We can play these. So distortion. Now I can free some of these that I don't want. Like let's free A. So now we can start to address things individually. Yes. Yeah, all of this will be on the GitHub again. And I apologize. Roy asked me and I forgot to do it. I'm going to get the Moodle up and I'll have the link to the GitHub. All of this. So again, Bearcat, just to be very explicit with it, GitHub. This is my GitHub thing in Sonic Programming, F21 content. We'll create a new folder that we'll call 2 September 24. And then I'm going to save this as 01 learning stuff in SC. Super useful file name. I'll open up my github.desktop app. I need to, whatever. So discard that. Created this file. I'll commit to master. I'm going to push it. It's going to tell me I need to fetch first. That's fine. I'll pull, I'll push. And now when we go to our Git repository for Sonic Programming, and I make it bigger so we can see it, and we go to F21 content, there's a folder now called 2 September 24 in all of this file, and all of this information. So you can copy and post it into SuperCollider for yourself. Just to be explicit. Yeah. That, no, that's not mine.
This is mine. Do you need something?
No, I borrowed it from a student.
Okay.
All of mine are broken. Everyone, Professor Michael Murphy, yes.
How are you?
Good. How are you?
Good. Is this your interactive bunch?
This is the Sonic programming bunch.
Little Sonic program.
Look at all this. Do you want to sit and learn code-based audio work?
I would love to,
Yeah.
but in a few.
Yeah. Have a great morning, Professor Murphy. What was your question, Bearcat?
When something is, when something is parenthetical, that defines, it requires that defines, that defines.
What do you mean?
Meaning, if you have A, okay, you have A equals, you need to.
Yeah.
If you wow. If you have A equals 2, A is a global verb, and everything is inside those parentheses. And outside of those parentheses, global.
A is an environment variable, meaning it's available anywhere in the supercollider environment. Any other variables that we defined using the keyword var, this is a variable, would only be available in the scope of these 4 lines.
So A is always global.
A is always global.
So you don't need to set a using the variable.
We don't have to declare and instantiate it.
Okay, got it.
That's poor practice if you're, so you want to be careful with this. It depends on how you're using it. If you need the variable to be global, make a global variable. If you need it to stay within the scope of the lines we're working in, keep it within that scope. Oh, I need to get better at describing things and not be so sleep deprived. But we're going to get there, and I'm going to help you all out. Lastly, A through Z is not particularly meaningful in terms of how you look at the variables. So we can also create, also in addition to the A through Z, we can create environment variables by, what's the word I'm looking for? Prepending a word with a tilde. So this is a environment. What? Defaults by reference. So dir is equal to 4. Now I can reference dir. If I store it, I can now reference it again later. The word is execute the line, just like we would anything else. So shift return sends it to the interpreter, it compiles it, and it puts it into the environment variable space. I can now also use dir, so I can say dir is equal to dir -8, and then I could reference dir again. Yeah. Tell me.
So I think it's so where this output signal what do you have to do? What is that?
It's just, we've attached the play method to this block of code. And just like any other block of code where it sends the last command to the post line, in a synth block, it sends the last line to the speakers,
And the last line.
which we've stored this in.
Okay, so that will always be the case. like the last.
We don't have to have that because down the last line would still just be Sine Os and it works. And what we're actually going to get to at some point is we're going to be very explicit that we will send what we're sending to the speakers.
So could you specify what, in a general sense, a synthesizer code block consists of? And what?
Not yet,
Okay, that's-
but I will.
Okay, cool.
but I
don't
will.
need to
Yeah.
worry about
Not yet.
it. Okay.
Please.
In this language, essentially, you run the code, as you, the whole code, the whole program, is loop. I mean, it has to be, otherwise, we don't have any orders.
Yeah.
So the whole thing has to be looped, or else it wouldn't.
What do you mean?
Meaning, it's a play, method.
Yeah. So let's dissect this here. So we've got a set of parentheses that just groups a bunch of code together, so it's all going to get executed as one block. Okay. I've then declared two variables, namespace sig, namespace freak, and initially I've assigned the value of 200, an integer, to this namespace freak. On line 65, I've then actually created a unit generator, mousex.kr, where every 512 samples, it's going to send me a value back. And it's going to be in the range of 200 to 400 based on the X position of my mouse. This value will get stored in this variable space free. On line 67, I'm creating a sine oscillator, which is another unit generator. I've attached the AR method to it, meaning make an audio rate signal. For its arguments, I've said, let's make the frequency of this signal equal to whatever is stored in this variable space frequency. And let's drop the amplitude or multiply it down by a factor of 0.3. We then store this signal in the variable namespace signal. Ultimately, this is the last thing that's part of our synth block. So this gets outputted to the speakers. And then we tell our synth block to play. I'm glossing over a lot still there. So
So the program's going to hitting the play is a method
of synth.
of synth, which is play is a method of synth, which is assumed by the bracket.
Yeah, this creates a, if we apply the method synth, if we apply the method play to curly Q brackets, the interpreter knows that this must be a synth definition,
Okay.
and we should create a synth from it.
And the loop is part of the method, which is why it keeps going, and then when it comes to.
Okay, I think I know where you're at. So thank you for being stingy on me on this. No, it's fine. Here's where we get uncomfortable. In real-time environments, when moving from a purely compiled offline environment to a real-time environment, the way that we deal with ongoing signals becomes slightly confusing for those of us who have spent a lot of time in a fully compiled non-real-time coding environment. I'm assuming that's where some of this confusion is coming in, because you're going, well, you've assigned a value to frequency, but that value is changing all the time. Right? Is that part of it? Okay. And what we're gonna, and I forget this because here's the clusterfuck part of my history is that this is the coding language I started in, was in SuperCollider. So I then went after that to C and then JavaScript and these other fixed compiled environments. So my brain flexibly was always fine with this jump, and I forget sometimes that this can be difficult. This variable namespace is not saying I'm only looking at a single value, but rather is referencing an ongoing signal. And then it's handing that signal to wherever it's being requested later on. And so what we do is we create a synth. And if we look at when I create this here, we create this synth group. And internally, the interpreter has actually created a complex structure of how the data is being passed around. To try and simplify it for us, though, we're just assuming a single variable namespace where we can reference the signal. You could think about it being looped, but really you want to think about it more like an audio studio signal flow. Essentially, we're telling the computer to create a synth and to patch, like a patch bay, right? Like with cables, patch the output of this whatever box. In this case, it's some sort of input device. We want to patch the output of this input device to the frequency input of this sound-making synthesizer, Sine Os. And then we want to patch the output of the Sine Oscillator eventually to our speakers. There's a lot of abstraction going on. Yes.
But how do you reference the variable? Let's set, like, for example, A as variable and set other variables, but for example, I just hit like A dot play.
So, okay, so we've set dir as an environment variable. We don't need to declare it. It's automatically declared with this tilde. We're gonna go sineos.ar. Notice we've created a function. I can now go dir.play. Say again. The squiggly signifies environment variable.
Okay, do you even have to do that for A through Z?
No, A through Z are set aside as environment variables. We don't really have global variables in SuperPipe because we are dealing with environments, but we're going to use those two terms interchangeably for the time being.
So I guess I'm still not getting any feedback from my computer. So I set
Set A equal to this squiggly parentheses block.
it, I did. I guess, do I have to include that feature out?
Well, you just have to make sure that the whole thing is executed.
Oh, do I have to execute this?
So, okay, so A through Z, when referencing, so this is what happened here with Matthew. Matthew added a tilde in front of his variable A, but that then becomes a different variable. This is stored in namespace A. This reference is nil. If I take out the tilde, because E is what's referenced.
It's still not. Fine, sorry. So you want to go. Now it's doing it. If I hit A dot.
So in this case, we're actually telling it already to play. So it's playing. And free it. Now, here's one more thing that gets you in trouble, and this is a great point, Matthew. If I add dot play here, we're playing, and notice I've created a synth. If I say a dot play again, it gets confused because we handed the synth to A, and we can't make it play again because it's already playing.
Oh, wait, so I can get it.
So if we've got a dot play, this is also going to get us in trouble. I can play it, but now I can't free it. Because we didn't reference the synth, we referenced the function. So I'd have to go B is equal to oh, here. Yeah. And this is, sorry, B. Okay, so this is the problem with an abstracted signal flow based language. That's why we're going to go slow. That's why you're going to do lots of small experiments over the next couple of weeks. They're going to help you get a sense of what's going on here. Okay. So here, create a function referenced in tell play method to the function. Pass a reference to the resulting synth. See. Right? Confusing as fuck. There are actually easier ways that we're going to do this next week. Okay, next thing.
So essentially, you need to have two different.
If you're going to do this later on. Yeah. Yeah. But we're going to show you why in a second. Okay. So we've got variables. Synth are okay. So a synth argument is a value which can be externally modified or added at the time of instantiation or while playing. Okay, so that doesn't mean anything to you at the moment. But if we do this, if we say A is equal to this synth, I'm going to use the namespace arg. Using the keyword arg. And what we're going to say is frequency is our initial argument. I'm going to set that to an initial value of 200. I'm also going to create a variable signal. Signal is going to be equal to sineos.ar frequency freak. Okay, I'll execute that. Now I can go a.play. Okay. Does this make sense? This is what we've done before. So we've created a function. We've assigned it to the namespace A. And then I'm telling A to be played. The function is everything between these two curly Q. I just haven't put play here. I'm passing the method play to this function on line 150. I declared it here at 140. I'm going to show you. Yep. So let's open up help on the play method. And we're going to go function. Whoa. Where did play go? Here we go. So play a synth from UGens returned by the function. So again, we've created a function here. And in line 153, we've passed the method play to this function. Play has the following arguments that can be passed to it, including arguments of the synth itself. We're going to get there in just a second. You're all going to feel okay with it. So we want to do it like this. So I can actually say play args. Is that right? And I believe I do it like this. So I create an array with freq. I'm going to say 1000. I can now reference this single function and instantiate it multiple times with new values in it with a single line. This doesn't seem particularly useful at the moment because our function is only 7 lines long. But if it was 1,000 lines long, we could quickly create a whole bunch of them with these single lines here. Great question. So the backslash signifies a keyword. Great question. Arguments are looked at as keywords when we're passing them in. It's an escape in some ways, yes. Okay, this is, again, we will continue to hit this stuff over and over the next couple of weeks. I know I'm glossing over a little bit of things. I'm trying to take into account different backgrounds of people so that we're not being too technical. Okay, but let's say we reference a.play. So in B and C, we have these two values. And I'm actually going to move 0.2. So now I can actually change a synth in real time. Okay, this is not mind-blowing. We haven't done anything crazy yet, right? But you can start to see the possibilities where if we can reference a synth that's playing in real time, we can actually tie into it and control it from other synths, other environments outside of SuperCollider, or other ways. And I'm doing that with this set nomenclature. Change a synth argument. And this is where, so let's call this synth func. Maybe that will also make life easier. So we could then play synth func if we wanted to. Likewise, we can play this synth func and we can assign a reference of it to synth 1, synth 2. Synth 1. Synth 1. 2, that 3. They're the same base code. And this is where we get into this idea of object-oriented programming. We've created 2 objects of the same type. So we're going to store a function. This is kind of represents our basic idea of a synth definition. We can then tell this synth that we want to play it, and we want to pass in an initial argument for frequency of 1000. We'll store a reference of that synth in the namespace synth1. We'll create a second synth object from the same synth function with an initial frequency of 100, and we'll store a reference of that playing synth in the namespace synth2. Since we now have references to both of these, I can actually change the values of these synths. Likewise, free them. I've never had to hit Command period. Yeah, it is. I'd bring earplugs. Yeah, it is. You haven't had an in-person class with me yet, have you, Bearcat?
I'm sure you're enjoying it now.
Okay, don't worry. I'm also going to do a lot of screaming this entire semester. They'll wake you up. 10 o'clock's hard for Sam. Good to know. Sam took a class with me. Oh, we had a couple of people who did a class last semester. We would 10 to 1 on Fridays. I really like this time slot quite a bit. It's a good time slot for me. Okay, this has been kind of confusing so far. So let's just back up and review. Again, we can create a basic synth. What we're doing here is between the curlicues is we're defining a function. We're passing the play method to this function, which creates a synth. We can notice in our node tree, which I pulled up by hitting server, show node tree, that we have a synth playing. Likewise, I can create multiple synths. And notice that all 5 of them are playing in my node tree. Kill them with brute force. I go command period or control period relative on PC.
You're running line by line. You're running line by line.
At this point, I'm running line by line. We could
You would run the whole thing.
run the whole thing by wrapping it in a set of parentheses. And as long as each line is post or is postbended with a semicolon, each of them is a separate instruction and will get executed all together. Not all together. I mean, they happen sequentially, but it's in such short order that we assume them to be all together. So I can either put in an opening parentheses and then brute force put in a closed one. I can also actually, I think. So if I highlight it and then just hit the opening parentheses, it automatically adds a closing parentheses. And then as long as my mouse, and do you all see on yours, when my mouse is by a parentheses, it shows me color coding wise the matching parentheses. So if I had an extra opening parentheses in here, and I put my mouse here, it's confused and it puts it here. And I think I want it to be up here. Or if it's inside of this, I'm going to really get a problem. And now it shows me if it's in red that it's not matched up and I've got issues. I need to go bug hunting. So I've highlighted line 3, and this is great, Charlie, because I don't know, I want to make sure this is the same. So I've highlighted lines 3 through 10 or 9. I'll do an opening parentheses, and it, for me, puts it at the beginning and end. Sam. Yeah, I'm just clicking and dragging. But the other thing that I was pointing out separately, and I should have given more of a pause, is that if my mouse cursor, or if my cursor is by a parentheses, it tries to show me the matching parentheses. So same thing here, if I zoom in, actually, let's do this. Notice with my parentheses now, I've got my cursor here, and it's my cursor was right here. And so it's showing me in red that these parentheses match up. How do I can't remember the key command to do that. If I move my cursor out one, it then shows me these parentheses match up in red. And likewise, if I move my cursor to the outside of this larger parentheses, it shows me that these two are matching up. Kind of makes sense? Where we get in trouble and where SuperCollider tries to help us is, let's say I've got an errant parentheses. this is something I commonly do. I'll add an extra closing parentheses. I'll go to execute it and I'll go, wait, why didn't it work? It should have grabbed everything there, but it's not doing it. I try to double click and it grabs it to here, so it's confused. I move my mouse around and I see this big red cluster. It's showing me I don't have matching parentheses. It's not as eloquent as it could be, but it's trying to. Then I can go bug hunting.
Well, I'm lost.
Me too, Bearcat. Totally good.
Okay, so this whole thing, everything on the right hand side, yeah, no, it's a command line.
Yeah.
Which is why you're not, you don't really run the whole thing.
You could, but yeah.
So when you hit go, it's going to run whatever whatever.
The largest outside matching parentheses are.
Right, whatever you're focused on.
So in this case, the largest matching outside parentheses is this opening and this closing. And so it'll execute sequentially these 5 ones.
Okay, everything can die with text.
It's not, because it's a real-time render environment, it's not quite like just a text editor. But it also is.
Yeah.
I know.
Yeah,
I will challenge myself to try and work on my language next week so it's a little bit more clear. Sorry that I'm not being as clear as I could be.
no, it's not you.
Super Collider throws it all out the window. That's why in some ways, okay, so the alternative to Super Collider are programs like PD or Max MSP, which CSound is still text-based. Max MSP and PD are patcher-based environments, similar to Touch Designer or other, where you literally drag and drop an object and then you draw a patch cable to the next object.
So,
Just like a big hardware modular synthesizer. And Super Collider is allowing us, what we're trying to get our brains to do is essentially create an abstract representation of a modular synthesizer in our brain through text. God damn it. Why? Because I don't like drawing patch cables. Is the simple reality of it. I gave Max MSP a try. I really like it. It's very capable. Ultimately, I don't like drawing patch cables. There are environments that I draw patch cables in because I like them better than trying to do, like I like Touch Designer more than open frameworks. I think it's a better environment. It's the same type of argument though. Open frameworks would be a C-based text-only environment for real-time work. And Touch Designer allows you to do this more flexible visual-based environment. Okay, so then we got to variables, and we have a variable declared with the name var, and its scope is whatever set of parentheses it's within. So I can execute this, and val is active for the entirety of this scope. Yeah. It means you have unmatched parentheses. So this is where, Matthew, if I add an extra parentheses in here, and I get this red line, if I try to collect this whole thing and execute it, and get this command line parse failed, it means that there's something wrong with your code. It could also be a missing semicolon. Oh, that worked, it shouldn't have, but it could be a missing period. It could be a missing comma. It's usually a semicolon, a period, or a comma. Yes. We're declaring a variable named val. We assign val reference the integer 3. We then override it with the integer 7, and then we pull it back and have it post in our post method. Same thing. We declare a variable val. We assign it initially the value of 1. We take val, multiply it by 2, and reassign it to the val, to the variable val. We then take that value and put it to the 4th power and reassign it to the variable val, and then we post it. Val, however, is not available to us outside of the scope of this parentheses. Val can store any type of information, including strings. Variables can store any kind of information in SuperPython. This is where the difficulty comes, including signals. As in the case here, variables in a synth. So we declare 2 variables, sig and frequency, both of which are signal variables. Well, actually, initially, frequency is a single value, and then we override it with a reference to a signal. This signal then gets passed to the sine oscillator. And it'll get constantly referenced. Then the output of sine oscillator is passed to the output of our synth. And so, as Charlie so astutely recognized, it's like a giant modular synthesizer in which you're patching the signal flow together. It's just we're doing it abstractly through text. Yes. I know. We're gonna go baby steps. Remember, you're gonna take a couple weeks where you're gonna be confused, and in a couple weeks you're gonna be like, "Fuck, I think I know what's going on." I promise. That's how it's gonna go. Sam. Yes, we are. No, we are. You're right. And we're gonna see. I was trying to decide if we would do that at the end of today or not. It depends on how much we get. Okay, so these are scoped variables. There is something also called an environment variable, which we can think of these as global variables. We can think of them interchangeably. Global variable meaning it's available everywhere in our environment. In this case, I create a function, and from that function, I create a synth, and I pass a reference of that synth to the global variable A. I now can free A without hitting command period. This is useful when working with lots of synths because I can execute 5 lines, storing them all in different synth or global variables. And I can put them individually. It's essentially an amplitude multiplier. It's multiplying the entire signal. So you remember our discussion here of our sine wave. So what mul does, mul multiplies the entire signal. So if we've got +1 as a default output value to -1, and we multiply this signal by 0.1, what's our new max output values on the plus and negative side? 0.1. So thereby essentially reducing the amplitude of this signal. But we could use this for other things. So here we have mousex.kr, and I've used range method, which is a shortcut for allowing us to set the range of mousex. I'm going to comment that out. I'm going to recreate this line, mousex.kr. If I do nothing with it, I'm going to turn my sound off. I'm going to turn it on. You're not going to hear anything. Why not? Say again. I'll come over there in 1 second. Well, it has a default range. The default range is 0 to 1. If I'm passing a frequency of 0 to 1, can we hear it? No. Bottom range of human hearing is 20 hertz. These speakers may go down to 52.
So it is playing.
It is playing. And if we execute this and I turn my sound down, you'll notice in our meter, it's playing audio. You might feel it.
Why is it?
Just release that desire for a while. We'll get there. We'll get to stereo. We'll get to stereo eventually. We're in mono land right now. Okay, so if I look at the help file for mouse X, again, help, I pull up with Command D, or if I right click, is there a way to get help? No, so I can go help. Look up documentation for cursor. Command D. Oh, I thought it took that. Okay. So let's ignore this example. Well, this is actually, can we come back to mole? Who asked about mole? We're going to come back to mole in a second, because that is one of my goals for today. But, yeah. So is there a question though? We can create 5 synths and we can reference them and free them individually. We can also create environment variables by prepending a word with the tilde sign. Yes.
For when you're doing this,
Either shift return to do a single line or command return if it's in a larger block. Great question. In this case, we've jumped around to a whole new clusterfuck where we're still dealing with environment variables, but now we're dealing with the complexities of synths themselves, in which we create a function and reference it in A. But notice we haven't attached the play method to this function. So if I execute A again, it just tells me it's a function. If I say A.play, I've created a synth from that function. If I want to free it later, if I go A.play, I'll create a synth. But notice if I execute A again, it's still a function, so I can't go A.free. It's not referencing the synth. This creates the synth. It's a function. It's a function. It's just what it's called is a essentially a signal flow diagram. And that's why I tried to be explicit here. We create a synth function in lines 152 to 160. And we can play that synth function, but we can't do anything with it.
so dot play is
When we're dealing with function-based synthesizers, ignore that statement for the time being because it'll come back later to haunt us. Okay, but for now, so I've created a function, defined it in this namespace synthfunc. I can create I can instantiate 2 objects of that type function and store them in synth1 and synth2. Okay, does everyone, this is huge. This is the part where we get really into some big stuff, because we've declared a synth function here, but we're playing 2 synthesizers. I didn't write this code twice, did I? So I've created 2 instances of that function. I would not be able to do this. So if I had dot play, it plays it, but synthfunc now is actually a synth that I could free. What do you mean?
So if we were to have this example where you included dot code in 159, you are creating a synthesizer. Synth func is a synthesizer.
Yeah, it's no longer a function. It's a
Yep.
synth.
Is there a way, is there a function or code to get it to play other than going to that block and running it? Does that make sense?
Mm-mm.
So if you don't include the dot play, you have the option in 163 to see like synth func dot play. If you do include the play in 159, you've created a synthesizer where the only way to play the synthesizer.
Yeah. So that's exactly it. If I try to now execute this line, you get a giant clusterfuck error message.
So there's no way.
Because play is not understood by a synthesizer.
Okay.
Play is only understood by a function. Shit, so much terminology.
Yes. And so if you assign like B equals synth func dot synth func whatever, is I'm just wondering if can you store a synthesizer as a function?
Yes, that's what we're doing here, I
Oh,
think.
shit.
That's what we're doing. So we're creating a function that's essentially a synthesizer. And they were saying create two of them.
But it doesn't load the dot play.
There's a more eloquent way to do this later on. We're going to get into
I noticed you don't have any I don't want to go through. You don't have any arguments defined on line 53. There's no prototype. So you can
it. Arguments are
say
defined on line 155. I'm defining my arguments for this function on line 155.
Okay. So, got it.
It is weird. It's weird. It's based on small talk. It's fucked up.
So if you want to set an additional argument to it, you have to be on line 155.
Yeah.
Oh, yeah. Oh, okay. Because this is a great show.
Quick aside, this is another error bug problem solving thing. In the back, what essentially happened is, sorry, I'm a jerk. Fletcher, sorry, Fletcher, I couldn't remember your name for a second. Fletcher ran into this problem where he's got a function block around the sine os, but the problem is that scope then doesn't include any of this stuff. So anything that's going to ultimately be our synth needs to be in the same function block. So you're getting into trouble in that you have curly cues around the sine off line. You're not including all the variables in the argument.
And curly keys are only used for synth.
Curly cues are used for
And we can do standard functions like we can in other languages. So we could say A is equal to a function where we've got argument val1, val2. So we could initially set these to 0 and 0. And then we could return a variable result is equal to val1 plus val2 A. I think I can do it this way. One. Let's see in a second. I don't remember this totally off the top of my head. This isn't something I normally do often. So function. So I can pull a function. Here we go. Come on, scroll. There we go. Come on.
This help browser.
You're gonna spend a lot of time in the help browser. Why are you not working, help browser? Okay, let's close that and try again. Help browser. Okay, well, I'll look that up again later. But essentially, yeah, we need to go over functions. We're going to go over functions in more detail later. We're just kind of glossing over them right now. A dot, I think it's actually A dot eval. All right. I don't remember. Anyway, we don't need that at the moment. Okay. So we created a synth function. We execute it passing in arguments. And the beauty of that is that once we have a reference of that synth, we can later change the arguments of it in real time. And we can free it.
And what allows us to
The method dot set on the synth.
is that, and is there anything we need to do when we're setting up the initial synth to allow it to be set later on?
The arguments are what we can set later on.
Okay, so you need to define an argument and then the dot set is.
Yeah, great question, Matthew. Thank you if I missed over that. I apologize. So whatever this is called, we could have it also be. So let's get a little bit more complicated here, just as a. Well, no. At any rate, so we're changing the argument, but we could have it be called whatever. So it could just be FR. Yes.
And so what is the backward slash?
In order to reference arguments, we're going to use a keyword nomenclature. And so this is how we represent that keyword argument FR.
Okay, that's how you reference old arguments.
It's how you reference arguments in functions. So this right here, we need that backslash to reference it.
Okay, square brackets.
Because it could have multiple square brackets represent an array, and we could have multiple arguments that we were setting. So amp equals to 0.1. Amp 0.5. Likewise, Yeah, so let's say we don't have it here. You say, why are you trying to define a variable? And we're not, we're trying to define a key, we're trying to reference a keyword
Okay,
or a
so
symbol.
just in general, when we're writing super collider, the backslash is the reference.
Yeah, yeah. Yeah. Okay. Bearcat, what was your question from earlier that I told you to put a pin in?
I was asking, I was basically asking about scope. I think I was asking about scope, everything beneath everything inside the parentheses, the local value, the local variable that basically A through Z are automatically global values.
Great. Oh, all right. So here's what we're gonna do. We're gonna take a 10-minute break. Because it's time. We're gonna take, we're actually gonna take a 15-minute break. We're gonna give ourselves 15 minutes just to relax for a second. We'll be back here at 5 to noon. Cool. I'm gonna update the notes from class. I remember what Bearcat you were asking. We're gonna get to it in a second.
Yo, Doc, can you hear me?
Yeah,
What's up?
not much. How are you?
Good. Taking a little break?
Yeah, 15-minute break.
Nice. Nice, man. Yeah, just scheduled a test for this afternoon
Good.
just to make sure because we got to care about our fellow man, you know?
You gotta care about the community.
That's it. No matter what anyone says, right?
It's true. Well, it's good you did this. It was good that I forced myself to think about recording anyway.
There you go. Yeah, was it a bummer to try to figure out how to do that or
No, I just needed to mentally think about it and realize I could just use Zoom to shortcut it pretty easy.
there you go.
So should be fine.
Cool, man. But yeah, just wanted to say hello, just popping in.
Appreciate it. Yeah,
Yeah.
we're gonna be back on at 5 till. You're welcome to hang out and passively watch, or there'll be the recording later.
Sweet. Dig it.
Cool.
Thanks, man.
Yep. Bye.
Yeah, how's your kid?
Good. Very good.
What's the kid's name again?
Otis.
Otis.
Yeah.
After Reading or what?
Just after a name we could both agree on.
Okay, cool.
Yeah.
What's the middle name?
Philip.
Philip.
Otis
Otis?
Philip Music.
Fucking sweet.
Yeah, that's it.
Yeah. Is it crying a bunch or what?
Oh, crying all the time.
I bet.
Well, and I didn't realize there's apparently an elevator company, Otis Elevators or something. And Greg Twig was pointing out the beauty of elevator music. So Otis music is essentially the equivalent of elevator music. Is Otis? Oh, I did not know that. Good. Elevator. Good, good. My knowledge of the Star Wars universe is minimal. Oh, funny. Sorry. All right, Cole, Bearcat, I'm gonna go use the restroom. I will be back. Weird. Yeah. Yeah.
I just got this. Audio called focus rate.
Yeah.
The focus rate solar.
Yeah.
And, it, first of all, it sounds really, really good.
Nice.
And surprising.
Yeah.
It's amazing how good the computer stuff is. But as I listen to it, once again having including the track. Going through my collection, I'm a metal. A lot of the music that I listen to very heavily compressed.
Yeah.
So I ran some tests on my office to see what the dynamic range was.
Uh-huh.
And on a particular track by a band named the Zero, I was telling you the dynamic, the overall dynamic range of the track was 0.5 decibels.
Yeah, that's quite small.
Is that generally done in mastering stage? Is that done anywhere?
That could be done anywhere. I mean, that could be done anywhere. That's going to include mixing as well. I mean, that's going to, in order to get that compressed, you're going to have to do it in the mixing stage as well. That is quite small. Yeah, I would imagine it doesn't sound great, but why they do that?
Yeah. I mean, I understand in theory that it makes a degree.
Well, in theory, it makes it sound louder compared to something else that has a wider dynamic range. That's exactly the point. That's exactly the point. You cannot undo it. No. You cannot undo it. Once it's done, it's done. Okay, let's get going again. Okay. So, so now we kind of have a basic understanding of how synths work. And I know that that's of various levels for everyone in here. That's okay. Again, we're going to kind of keep chipping away at this block of black box until it becomes more and more clear over the course of the semester, rather than lingering forever so that you fully understand all of the details of synths right now. I'd much rather get us trying to get creative this week and next week than technically perfect on point. So I'm going to create for the time being, I'm going to create synths in the following manner. Synth func that will assign to a synth function. Any arguments I've got, any variables I've got, and I'm always going to include signal for one of those. Now, that actually, I did not think that was like that. So we'll keep that out for the moment. So, signal sine os.ar. Frequency for the moment, we're just going to set to 200. We'll leave it like this. Okay. And for the moment, we'll go synth func dot play explicit. Remember, I can view this synth by pulling up show scope. And I can see now I have a sine oscillator, and I can actually grab these little bars to see how much of it I want to see. We'll leave that up for the time being. Again, to get the scope, I'm just going to hit this. I'm going to show scope. Okay. Yes. Yep. Yeah, we don't need any of that. This is all just extra nonsense at the moment. Great question, though. So, there are two ways to affect amplitude of a signal. One, we can include the mole argument, and I could say 0.1. And now notice it's far less in amplitude. Depending on how I want to deal with this amplitude, I could also reference the signal multiply it by 0.1 and reassign it to itself. We get the same effect. Okay. You can use mole, yeah. It depends on how you're trying to deal with this. And there are reasons why you might do it this way versus internally in the sine oscillator itself. Yeah. Yeah. Yep. It just sends that out. Yeah. Play is happening right here. This is just the last line of the function. Essentially, you can think of it that way. Loosely, but you can think of it that way. Okay. So, let's say that we wanted to have two sine oscillators in a single synth synth function itself. So we're going to have sig1, we're going to have sig, which we're going to label out sig. We're going to have sig1, we're going to have sig2. So sig1, out sig, sig2, .ar, freak. What is our other one? 200. So we'll set this one to 300. Okay. Now, why aren't we hearing anything? Yep. So let's say I comment that out and we play it again. Now, why are we only hearing one sine oscillator? I'm not overriding signal 1. Notice I've created two variables, sig1 and sig2. can we get two sine oscillators potentially to play? Within a single synth. Yeah. Can't do dot play after these. I mean, what we could do, of course, is we could grab, let's just assume here for a moment, we could have done this. And we'll do away with that. We'll do away with that. Okay, well, now we're able to play two synths, but notice I've got two synths here. I want only one synth, but to use two sine oscillators. What other ideas do you have? Ah, and how would I do that, do you think? So let's see what happens here. Maya, thank you for taking a shot in the dark. So something is happening. Let's now outsig equal to outsig. Now how many sine oscillators do we hear? How many do we hear? One. Oh, we're hearing two. They're actually going together. And we can see that. So let's say we put this to 800. We can zoom in here. Hopefully. And we can essentially see the larger sine wave and the smaller one placed within it. But notice we still only have one output. We'll deal with that later. So in theory here, we can actually concatenate and make multiple synths doing this. Yes. That's exactly right. So 200, 800, we'll stay in not quite multiple, so we'll do 12. And we'll do something like 16. So we now can hear 4 individual sine oscillators in a single synth. Yeah, it's that simple. And just really quick, 1 second. Another thing we can do is on a synth function, we can actually call another argument called plot duration. And we'll say 200. So we'll go 1 divided by 200. I think this is what I want to do. Yeah. So now we're seeing the largest one divided by 200 for duration ends up being how long? 200th of a second. If our longest frequency is 200 hertz, that means we're going to see a complete period of that long frequency. So we see here essentially this larger 200 hertz frequency. And then superimposed upon it, the other 3 frequencies that are of 200 multiples. Say again? Super collider for audio analysis. You can, yeah, you can. Yeah, you can do, actually, we'll do a lot with FFTs later this semester. What type of synthesis is this? What is additive synthesis? Can one of you give me a definition? It's pretty, yeah. Adding oscillators together. Okay, so this is one of the earliest forms of synthesis, right? This makes sense. We got an oscillator. We can put 4 oscillators together, make a complex signal. In the early analog days of synthesis, what was the drawback of additive synthesis? Why was it not the most predominant form of synthesis? Limited channel, limited resources. Essentially, if you want to have an additive synthesis synthesizer, you need to have oscillators for each of the number of frequencies you want represented. So if you're trying to have some sort of frequency that's representative or has comprised of 100 different frequencies, you have to have 100 oscillators. It becomes really expensive. No, well, they were monophonic synthesizers, but the synthesizer could have multiple oscillators in its path. Okay, so this is additive synthesis. This essentially allows us to create, again, a complex wave. Oops. We can have both these together. So this is what it ultimately looks like, and we can still see this right here. Yeah. Well, how would we do that? That's a great question. I'd really like you to tell me how to do that. Who else has got an idea for that? Keep going though with your looking it up. Who's got, but anyone has an idea, start shouting it out. Yeah, you're getting there. Keep going. So what do I need to change in here? Line by line, what would I need to change? Yeah, the frequencies. So what if I did something like this? What if we pass in an argument that was, well, we'll keep it on our variables for now. Now, one thing we can do is we can actually have multiple variables. So we'll have freq. We're gonna have freq equal x.kr. We're gonna use this range method, and we'll set it from a base frequency of 80 up to a max of who cares? 1400 exactly. Okay, and now I can pass in freq. What's this going to do? Yeah, so what do I want to do? Plus. I can do plus, so let's do 200, 400, 800. Will it? We're adding. So let's say we've got 80. Let's make this easier. So we'll do 200 to 1400. That's quite good. Consonant, right? So what frequencies is this comprised of right now? Yep. Okay. And then let's just to make life easier, 2000 over here. On the right, what are my frequencies now? So the relationship has changed. So what do we need to do to keep the relationship the same? Multiply. So we'll go multiply by 2, multiply by 4, multiply by 8, something like this. Now the relationship of all 4 frequencies stays the same to that carrier or base frequency. And if we had a more limited range, it would probably sound slightly better. Cool, right? Okay. So this is an example of additive synthesis. And let's, oh yeah, using a moving frequency. We could do the same thing if we wanted to eventually do it algorithmically instead of using the mouse. And we would set an initial value of 200. Now here I can go, sorry, synth1 is equal to s1 dot set freak when you're using an argument, you do. Here's the problem otherwise. If I don't, and I try to play this, nothing comes out, which is fine because it's got no value initially to deal with. It worked. It didn't create an error notice. Like it worked and it's playing. We can verify it's playing, but until I set a frequency, it doesn't have any value. It doesn't know what to do. So what do you mean? The escaping doesn't matter. This could be whatever. I could call this happy. I still have to escape it because it's not. I'm not actually escaping it. It's looking at it as a symbol. It's not escaping it. It's turning it into a symbol. So don't think of it as being escaped. We're not escaping things. These are now symbols in SuperCollider. So we've created an argument called happy in our synth definition. To reference it, we pass in the symbol for that argument. Say that again. Yeah, you just instantiate it with some sort of base value. So let's say amp, we initially set that to 0.001, and here we'll multiply by amp. We're playing, it's just so soft you can't really hear it. So then I can set s1.amp set amp 0.2. You don't need an array. I forgot. But not 250. Oh, because we're defining a function here, and then we're setting that function in real time. Yeah. Cool. Okay. Yeah. Yeah, not really. Passing the set method is for real time because we're affecting a synth. Remember what we did here is we defined a function. From this function, we created a synth. And now we're passing the method set to that synth. If I pull up help on it and I scroll down with my mouse because for some reason it's not working, and I pull up synth, set the values of one or more controls in a synth. Yeah. Okay, cool. Now let's say we wanted to do a different type of synthesis. No. Let's do amplitude modulation. Okay, so what is amplitude modulation? Yeah, something along those lines. So we'll have frequency, and we're gonna get to it. 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 We're gonna say carrier frequency and modulation frequency. Okay. And modulation frequency is going to be set to sine os. We're going to say .ar, and we're going to set a frequency of for the moment we'll go 1, and a range. And we'll get to this in a moment here. And then our carrier frequency, we're going to be sine os .ar, and we're just going to leave that frequency to 3. We're going to multiply it by our modulation frequency. And then we're going to say out sig is equal to CF times, and we'll actually keep amp in there. Amp equal to 0.3. Okay. So in this instance, we're going to be creating a sine oscillator or a sine wave, and we're going to multiply that sine wave amplitude by another sine wave. So what do we want that range of the multiplied amplitude sine wave to be, or our modulation frequency? 0 to 1. 0 to 1. And we can actually affect this later on. So let's see here if this works. So we hear now this modulating amplitude. We can set our mod freak. So something like 200. Yeah, let's instead for the moment, let's do this. X.kr range, we're going to go from 0.1 to so I'm passing in my mouse value to set the frequency of our modulation frequency. Yeah, it's starting to actually get complex. And I'm going to add in something new that we haven't done before. A method called poll. Notice poll shows me in the post window the value of whatever I pull in at a certain frequency. In this case, it's showing me what is the value of mouse X. Right now, mouse X is 0.1. So now the modulation frequency is essentially, if we're at 1 hertz or so, 1 time per second, we hear this pulse. And it goes from 0, so there's nothing, to 1, so it's as though it's being unaffected. As we come up, we're now roughly 5 times per second hearing that pulse. Modulation frequency, because what we're doing is we're taking our initial carrier frequency, this normal frequency value of 200 sine oscillator, and we're multiplying it by another sine oscillator. It's not being canceled out. What's happening is that so here's our here's our carrier frequency, the original sine wave, and it's at a frequency of 200. If we multiply it by 0, what happens to this waveform? It goes flat. If we multiply it by 1, what happens to this waveform? It's the exact same. And if we multiply it by 0.5, what happens? It's half the size. 0, 1. Trying to draw with a mouse is very difficult for me. So what happens is that in time, this value right here, modulation frequency, is going from 0 to 1 at a frequency that we've determined by our mouse X unit generator. And that's then multiplying the amplitude of our carrier frequency, or our initial sine oscillator. So again, if we're at 0.1, essentially once a second, we're able to hear this wave, and once a second, we're not able to hear it. 400. Oh, that's the range. So as I go up, we start to hear this pulsing. At what point do we stop hearing amplitude pulsing and start hearing a single kind of signal with multiple frequencies? When the modulator wave hits the range of human hearing, or 20 hertz, we start to hear something known as sidebands. So notice right now, my modulator frequency is at 22, and it stops sounding like a single wave that's pulsing, and it starts to sound like a complex waveform. Side waves. It's actually sideband frequencies is what it would properly be called. Sideband frequencies. So if I go above 20, you start to hear these moving sideband frequencies. It's modular synthesis. In this case, amplitude modulation. And there are places where it'll sound consonant to us, and places where it'll sound clusterfucking. So again, our modulation frequency. The side bands are going outside of the carrier frequency. So we constantly hear 200. We always hear that kind of 200 as our base frequency. If I change S1 dot set our base frequency to something else like 300, 400, it's going to go up an octave. So whatever the carrier frequency is at, this essentially equals our perceived frequency. Our modulation frequency creates side band frequencies, which add complexity to timbre. Is one way to put it. Yeah. Three weeks. Yeah. Yes, I'm not very good at drum sounds of this, but we'll get to that. It is possible. It's possible to use Super Collider to create dance music. It depends on what you're trying to get at. The reason you might use Super Collider to create dance music is because you want to give agency to the computer. Yeah, or you can use the scheduling functions of Super Collider to create complex algorithmic compositions and then drive the synthesis engine. Yeah. Like microphone in? Yeah. Yeah, great question, because that is something we're going to need. We're not going to use that this week, but we will get to that. Yeah, you can definitely record. Yeah. Well, the other thing I do, so one of the reasons I have all of these extra audio interfaces here is I oftentimes just inter-application route my audio from Super Collider to Ableton or Pro Tools, and then record directly in the DAW, as though this is just an external synthesizer. Okay, what I'm really excited about is the amplitude modulation seemed to peak some eyes up, so that's great. Cool. Let's do the next one. What's the next follow-up to amplitude modulation? That's exactly it. And what is frequency modulation? Yeah, so carry frequency, I should have wrote up here, carry frequency, CF is modulated. CF's amplitude oh, and just to be also explicit here, could set this to something else like 0.5, and that's going to affect sidebands. We can still hear them, but they're not as loud amplitude-wise. So essentially, the range of the modulation frequency affects the mix of the sidebands. Say that again. No. You would 20, somewhere around 20. So let's do that. Yeah, it still sounds like pulsing to me, but that's because I know what I'm listening for. Somewhere right around here above 20, it starts to sound like sidebands. It stops sounding like a pulsing audio. No, it's literally just pulsing. Oh no, man, you're just learning in real time. You're just going, fuck yeah, black box. I have no idea what's going on, but it seems cool. So human range of hearing is 20 to 20K. When we start pulsing an audio wave, not for me either. When we start pulsing the amplitude of an audio wave, if we're between 0 and 20 on that pulsing, it sounds like a pulsing audio wave to us. Okay? Any signal, anything that we start going above 20 hertz, whether it's a single impulse, whether it's this amplitude pulsing, when we start going above 20 hertz, what happens? We get into the range of human hearing. So we start to get these phenomena that sound like frequencies of some sort. So essentially what we're doing is we're creating a complex waveform. Because we're multiplying it by a frequency that's in the range of human hearing. Yeah, that's it.
Oh, because it's not, when it's not in the range of human hearing, it's not canceling it out, so you can't hear it, so it's
Well, it sounds like a pulsing audio wave.
right.
Yeah.
But if you were an elephant, you could come.
No, maybe, but probably. It'd have to be at a certain amplitude. But the flexibility of your brain right now is impressive. That it's working to keep up so hard. Truly. Okay. So same thing, modulation frequency. We're going to have 0.1 to 400 with a range of 0 to 1. But we're going to modulate the frequency value itself. Now, so if we have a frequency of 200 and we multiply it by 0, what's our frequency going to be? Nothing. And we multiply it by 1, what's it going to be? It's going to be 200. We don't want this because we want to still create this perceptual evenness on both sides. So we actually want to go so this is, so there's range, and then there's exp range, which creates an exponential mapping. So we're going to do an exponential mapping, and we're going to go from what? We'll go from 0. Oh no, this is 0 to 1 is fine. Hold on a second. I need my brain to catch up. We want to go from let's say, just for the moment, we're going to go from 0.5 to 2. Now, why do I want to multiply it by 0.5 to 2? Did everyone catch that? Exactly why. So 0.5, and we actually are going to do exp range. So it's exponential. If we've got a frequency of 200 and we multiply it by 0.5, what's our resulting frequency? Yeah, 200 times 0.5, 100. Everyone okay with that? 200 times 0.5 is 100. And that is 1 octave below 200. Am I missing anyone? Because I know some of you haven't taken basic sound classes. That's fine. If we take 200 and multiply it by 2, what do we get? Which again is an octave up. Yeah. And frequencies based on an exponential scale. So we're just going to listen to this for a moment and see what happens. So what's happening? Yeah. So what is our frequency range going between? Yeah, at a rate of 2 hertz. So we perceive this actual frequency change. And at what frequency on our modulation frequency can we expect to stop perceiving a single tone, start to expect perceiving around 20. Another thing we can do is we can multiply our MF by some value so that it's not quite as strong. Dr. Coasters offers a MUST 210, which is a synthesis class, and he presumably goes into detail on some of these algorithms. So anyone wanting to dive deeper into that, go into that. I can also provide a link to some basic literature, and we can retouch on this, some of this, how this is happening perceptually later in the semester. All really cool stuff. Same thing, yeah. (200) plus 200 as a frequency. If we add 200 to it, we perceive that as an octave. 200 to 400. If we take 2000 and we add 200 to it, do we perceive the difference between 2000 and 2200 as an octave? No. Perceive a difference, but you would not perceive the same difference. That's what I mean by logarithm, and or exponential. We'll get into that more later. I'm sure that's going to have to come up. Well, again, it's all based on ratios as opposed to linear values. So that's why if we multiply 2000 by 2, it's going to always get to an octave for us. If we multiply 200 by 2, we always get to an octave. If we add 200 to 200, we perceive an octave. If we add 200 to 2000, we perceive like a step in a chunk. $2,000, double it. It's always double. An octave is always double relationship. And this is where our man Pythagoras way back figured some of this out in string ratio lengths. And so he started to play around with acoustics, the idea of this kind of basics of acoustics and the physical relationships of it, and discovered that if we take a string and we have it, we create an octave. If we have it again, we create another octave. Those string lengths are logarithmically or exponentially related to each other. Fucking hell. So cool. Okay. So we've done amplitude modulation, or we've done additive synthesis, amplitude modulation, and frequency modulation. And within these things, we can use the set method to set certain arguments, or we can directly affect things in real time using mouse X or mouse Y. Likewise, we could actually add these things together using amplitude or concatenation, as Maya so eloquently put it. So we could put an additive or an amplitude modulation signal and concatenate it or add it with a frequency modulation signal and create a further clusterfuck of complexity. Real quick side note here, because it's important to get this one. This is a classic bleep, bloop synth. So we're going to introduce one more using a step-based noise UJED. We can create our classic bleep, bloop. Noise. Okay, just because this is an important one, I think we'll borrow all of this again. And outsig. Okay, we'll stick with some of this. So in this case, we're going to go our modulation. But what we're actually going to do, we're going to call this mod freak, and amplitude variable will be freak sig. So our frequency is going to be equal to this new unit generator, LF noise 0.ar. We pull it up. LF noise generates random values at a rate given by the nearest integer division at the sample rate by the frequency argument. What? Yeah. So we're going to go like this. We're going to go so that we can have a sense of what it does. Frequency of 10. So 10 times per second. Dot plot. Duration 1. And then I'm going to grab this line, ignoring the variable, because it would cause me an error otherwise. So we can see, can you all see clear enough on that monitor? Kind of, yeah. Essentially, we get a signal that is of various values in a stepped fashion. 0.1, 0.6, 0, negative 0.3 something, etc. Yeah. So I'm going to do away with this now. Actually, here we're going to pass in our mod value. And we're going to use our X range method. And we're going to set a range of what? What do we want to set? Yeah, we're going to say in an octave. So we're going to go 250 to 500. And finally, we'll pull on this. But we're going to be a little bit cleaner in our code. So we'll go frequency dot pull. So this is going to tell us what our value is. And our mod freak value, we're initially going to set to 1. Okay, moving along. So now we got sig, sine oscillator, frequency. We're passing in frequency. And then our out sig is going to be set to sig times amplitude, which we'll keep set there. And we'll set this to 250. And actually, I should do this like set to so we can see now that we have 4 chunks of various frequency values. We can hear that. And we can also see every second a random value based on this noise unit generator. Where? Here? This is for the plotting. So this plotted 4 seconds. Great. We're actually, it's lasting 1 second because we set the frequency value of this unit generator initially to 1. If I go mod freak 10, click blue. Yeah! Yeah, you can. Yeah. That's a great question. So work it through first, Bearcat.
So you're sending, you're sending them on. You're sending. You're sending the.
I'm listening to you. S1 is defined in line 364. Because it's a weird fucking language. Because no one should be writing this in text. But your professor's a psychopath, and you thought it'd be fun to do this adventure.
So that's saying that the so it's modulating the area of practical. So when it goes on to 368, frequency of that I got 30 every
So it's times per second. So change the frequency 1 time per second, change this frequency 10 times per second, 30 times per second, 600 times per second.
So S1, so you're getting 4 tones? No.
Mm-mm. 1 tone. But again,
The first time.
yeah, so that's a great point, actually. If we take this. It'll never change again because we have a frequency of 0. So it's whatever was last set. I can turn it on again. Oh, except that, yeah. And there are other types of noise. I don't want to cause too much of an issue, but. So LF noise 1 is a linear stepping between points, and LF noise 2 is an exponential stepping between points. Again, this is real time, so we're able to touch this and change it. Yeah, this is the beauty of real time. It becomes so flexible as to be dangerous.
but it's changing, based on, yeah, audio.
Yeah, and actually, you're right. This one should have been KR. Doesn't matter. Great call, man. Okay, real quick, because some of you have been so whiny about it. we're going to say variable signal out sig. In order to create a stereo mono signal, we must expand our signal to 2 channels. So we're going to say signal is equal to sine os dot AR. And we're going to set a frequency of, well, we'll just copy this whole thing actually. And we don't care about this other code, these other comments for now, so we'll do away with them. Here's the magic. I'm going to create an array. Remember, we're a zero-based system now. So this is 0, this is 1. We got fucking stereo, everyone can be happy. Not true stereo, but mono stereo nonetheless. I'm no longer passing a single signal out. I'm saying let's pass a signal to both left and right channels. I've created an array with 2 values, and so it knows to put that to 2 output channels. Oh, I thought I could do nil. Let's see what that does. Yeah, and that speaker's blowing as fuck, so. We'll get more into this next week. What does this mean for us? Yep. What else does it mean for us? What if we did freak left, freak? Oh, here, let me do it this way. This is not going to be well documented, and I'm sorry about it. And I know everyone's antsy to probably get out of here. So, right. So we're going to take this. Right. And you're going to be really angry at what I do now. But that's okay. Outsig. And here, we're going to create an array with freak left and freak right. The ability to do multi-channel audio in SuperCollider is stupid simple.
That's awesome, actually.
Stupid simple. So you can do up to a couple thousand speakers in SuperCollider pretty easily. Yeah. That's why the array-based system is nice, because it makes multi-channel audio real easy. But there's a great scheduling system for dance music. And I do it for all kinds of live processing of signals, whether I'm in bands or processing by myself, because there's great microphone input signals. We're gonna go deep, guys. Mhm. Yeah.
It'd be so cool if you set up like 8 speakers, kind of all doing the same LF noise, and then after like 10 seconds, they split off into 2 different LF
Fuck me,
noise,
I
and
hope
then
that's a project you do this semester. It's gonna be fucking glorious.
And then as you go further, they become more and more.
Okay. Did we get through everything I wanted to? I don't know. We'll look at some of it. I'll send out an email. Your assignment for next week is a sketch, just playing around. Sine oscillator, LF noise, mouse X, mouse Y, synth using set. You could do additive synthesis, subtract or additive frequency modulation, amplitude modulation. I don't care. And there's not going to be a definite beginning and end. You're just going to create some sort of sound. And I want you to just play with it a little bit. And we'll come and we'll listen to about 5 to 10 seconds of each person's next Friday. I will send an email with that information.
there's a lot to be talked about.
Yeah.
I'm feeling a little bit like you gave me a test on Monday. I'm kind of feeling it.
There are no tests, but yes, keep going. Yeah, be very derivative right now. This is, we're in very much derivative land. I don't expect you to go create your own sonata in Super Collider. That blows my brain right now. I expect you to be like, I made a theremin, just like you did 2 weeks ago, but I did this extra cool thing to the theremin. Sam, you had a question? We are going to submit the code on Moodle. I'll get a Moodle up and running. I'll download all the code examples and I'm going to execute them live on my computer. So we're not recording anything. It's not audio files. It's literally submission of code. And I will also go over GitHub next week for anyone who's interested. Anyone who has questions, I'm here for a few minutes if you got some questions. While I clean up. Yes. And I will send that link out again. Yeah, have a great day, Fletcher. Matthew? Ready? Okay. Lovely. We can do sports.